Video 2 for physics. So we are going to be learning how to calculate equations for fields. I am going to do this in a two-part video. So the first one is going to be on gravitational fields and the second one will be on electric fields. So you are going to need your notes package open to equations for fields. You are going to need your data booklet open to page 2, and you are going to need a scientific calculator. So I did post this one on Google Classroom on the stream, so you're more than welcome to open that up and follow along with this one. So in this note package, I'm going to skip this part, so just ignore that. Ignore this. We are going to move straight on to gravitational field strength. Okay, gravitational field strength is the number of newtons per kilogram that a test body will experience at a given location from the source mass. So before we talk about what that actually means, we need to discuss a test body. So what is a test body? So if you watched the previous video, which you should have, about a few lines, it explains what a test body is. But a test body is an object reacting to a field, whether that be an electrical field, a magnetic field, or a gravitational field. Okay, so it says the number of newtons. Newtons you would have learned in grade 10, if not grade 11, is a force per kilogram, so that's a mass. So it's a force on a mass that is going to experience, that is going to experience a different force at a specific location from a source mass. So from that object that has the gravitational pull. So the closer you are to Earth, or the center of Earth, the stronger the gravitational field is versus further away. Okay, so my calculations. So in your data booklet, it tells you your gravitational field strength. So these are all your variables. So little g is representing magnitude of gravitational field strength in newtons per kilogram. Okay, magnitude simply means how much, so it's a number. So this is gravitational field strength, so little g. So little g equals big GM over r squared. So little g equals big GM over r squared. You need to make sure you have brackets around the top before you divide by r squared. Now, the important thing about all of these variables is your units. So gravitational field strength is in newtons per kilogram. Big G is representing a gravitational constant. So this is 6.67 times 10 to the negative 11, Newton, and then there should be a dot in the middle, meter squared per kilogram squared. Mass must be in kilograms, and then your R, which is your radius, must be the distance from the center of the source, and it's measured in meters. So you must make sure you're in kilograms, and you must make sure that you're in meters. Okay, the next one is gravitational force. This is the force that is exerted on the test body by the gravitational field. So basically what this is talking about is how much force is being acted on a certain object, depending on where you are. Okay, so going back to the data booklet, so force right here of gravity equals mass times your gravitational constant. Okay, so your gravitational constant, which is G right here. Okay, so we're going to put that in our formula here. So force equals mass times your gravitational field strength. So mass must be in kilograms. Must be of your test body. A lot of students mess this up because they think that this is the mass of the object that has the gravitational pull. but we're trying to calculate what is the force exerted on the test body. So the mass has to be of the test body, not of the object that has the gravitational pull. Okay, so let's do some examples. So Earth has an average radius value of 6.37 times 10 to the 6 meters. So this is your R, because it's telling you your radius. Well, Earth's mass has a value of 5.98 times 10 to the 24 kilograms. So this is your mass. So we have meters and we have kilograms. We need to double check if those are the right units. Okay, mass must be in kilograms. We're good. Okay, radius must be in meters. Okay, we're good. So we don't have to convert any units, which is awesome. So then it's asking you to calculate the gravitational field strength at Earth's surface. So you're trying to find G. So I'm going to list my variables to the side. G equals question mark because we don't know it. R is 6.37 times 10 to the 6 meters. My mass is 5.98 times 10 to the 24 kilograms. And it doesn't give me anything else. So let's write our formula that has gravitational field strength. So it's asking you to calculate this so you know your GM over R squared. Okay, I'm solving for G. My unknown is on this side, so I'm good. Now I just need to figure out what big G is. Big G is that constant number of 6.67 times 10 to the negative 11. So let's double check that I did write that down. 6.67 times 10 to the negative 11 Newton dot meter squared kilogram squared. So Newton dot meter squared per kilogram squared. Okay, now that I have all my variables, all I have to do is substitute in. Now I'm going to drop my units just because then I have more room. So 6.67 times 10 to the negative 11 times my mass of 5.98 times 10 to the 24, close my bracket, divided by, now my R is 6.37 times 10 to the 6, and I need to square just that because it's R squared. So now plugging this into your calculator is the very and most important part. So I highly recommend that you know how to plug this into your calculator correctly and you get the exact same answer as I do. If you don't, please send me a remind message and I can do my best to help guide you. Okay, now we need to punch it into our calculator. So if you are using a TI-83 calculator, TI-84 calculator, it will be a bit different. So I'll try and talk you through that. If you are using the calculator that is posted on Google Classroom, so this one, I'll show you how to do this one first. And as I am talking through, I will explain the TI-83. Okay, so to use this calculator, we need to first put our bracket in. So bracket 6.67, 6.67, and then we need this times 10 to the exponent negative 11. So in the TI-83 calculator, what you are going to do is you are going to hit the second button, which is usually a different color. TI-83, TI-84, it's either blue or orange. Okay, so you're going to hit that button, and then you're going to hit the comma button, and an E should pop up. What that E means is times 10 to the exponent, and then all you have to do is put in negative 11, and then that puts in this 6.67 times 10 to the negative 11. Okay, but in this calculator here, it's a bit different. All you have to do is hit this exponent button, and it puts in the times 10 for you. Okay, now when you're doing negative 11, make sure it's not a minus sign. So the negative 11 is down here. So I think for this one, we have to put it in 11 and then we hit the negative. Okay. In your TI-83, TI-84, you hit the negative first. Okay. So we don't have to put the bracket in yet. But since I already hit it, it's totally fine. So we're going to hit times, bracket again, because we're going to put this in here. 5.98. And again, exponent. And now we have 24, bracket. Okay, Since I didn't put my brackets around the outside, I need to make sure I multiply these two first. So I'm going to hit equals. Okay, so that gives me this huge number. I need to make sure that huge number is calculated before I divide, which I just did. So now I can hit divide because I want to divide that huge number by whatever this is squared. So I'm going to hit, you do not have to put brackets for this, but we'll just put them just in case. 6.37, and again, exponent 6, and we need to square that. So my squared button is right here. And then we're going to hit enter. Okay, so there's my answer, 9.8, and we'll just put 3 digits down. On most of your tests, I will say record to 3 digits, record to 2 digits. So for this one, we're just going to record to 3 digits. So the 9, the 8, and the 2. But you always must make sure you round. So that 9 tells that 2 to round up to a 3. So my answer should be 9.83. Now, looking for units. Just use your data booklet. So gravity is newtons per kilogram. So we're going to put in newtons per kilogram. Box in your final answer. Whoops, kind of went a little bit lower there, but it is what it is. So there's your first one, which is pretty easy. Okay. B says a person with a heavy backpack has a mass of 100 kilograms. So it says the person has a mass of 100 kilograms and is a test body for the gravitational field. Calculate the force exerted on the human. So we're now trying to calculate force. So force equals question mark. The mass is 100 kilograms. And I need to calculate, or I need to figure out what my gravity is. So with regards to my gravity, gravity is previously calculated. So question 1 is connected to A and B. So A is 9.83 newtons per kilogram. Okay. Now my calculation to calculate force is mass times gravity. So force, and yes, you can put of gravity, is mass times gravity. So force equals 100 kilograms. You don't have to put your units in, that's totally fine. 9.83 newtons per kilogram. You might already know the answer to this off the top of your head, but if you don't, go ahead and use your calculator. So we have 100 times 9.83 equals, so 983. So my force of gravity is 983. Now kilograms gone, because there's one on the top and one on the bottom. You're left with newtons. Okay. Get rid of this so that you can actually see. Okay, example 2, I want you to try on your own and then check if the answer is correct. Okay, and then try number 3 on your own and check if the answer is correct. And you can do more examples if you so wish with this one. But I am going to skip those. Okay, good luck. If you have questions, please send me a message on Remind.